We're counting down the 6 leading culprits behind engine RPM fluctuations at idle. From elusive electrical gremlins to quick-win mechanical fixes, each entry reveals a critical cause that can leave your car surging at a stop. Some issues are overlooked yet essential to rule out, while others catch even seasoned drivers off guard. Which problem tops the list as the most common trigger? Let's kick off the countdown with number 6. Voltage instability is an often missed cause of idle RPM surges, but it takes less than a minute to check. With the engine running, connect a digital multimeter to the battery terminals. Healthy charging systems should show between 13.5 and 14.5 volts. Anything below 13.5 volts means the alternator or battery isn't supplying enough power, which can send the ECU into confusion and throw off idle control. If the reading is low, inspect the alternator belt for signs of slipping or glazing. Squealing noises or visible cracks point to mechanical trouble. Ruling out electrical issues first sets a solid foundation for further diagnosis. Once voltage checks out, you can move on with confidence to airflow and fuel system tests, knowing your car's electrical backbone is reliable. A dirty engine air filter is one of the fastest things you can check when your idle is acting up. Pop open the air box. Most filters are held in by a couple of clips or screws. If you see leaves, dust, or the filter looks dark and clogged, it's time for a change. A severely blocked filter restricts oxygen, forcing the engine to run rich, too much fuel, not enough air. That imbalance can make the idle rough or cause the RPMs to bounce. Swapping in a new filter, which usually costs between $15 and $30, takes just a few minutes and can instantly smooth out idle problems. Always check the filter before moving on to more complicated and expensive diagnostics. When basic checks don't solve the idle surge, it's time to look at the sensors feeding data to your car's computer. The ECU relies on signals from the mass airflow sensor, oxygen sensor, coolant temperature sensor, and throttle position sensor to keep idle steady. If any of these sensors send the wrong voltage, the computer miscalculates fuel delivery, causing RPM to jump or dip. An OBD2 scanner is your first tool. If you see code P0101, the MAF sensor is likely involved. To go deeper, use a multimeter. On a cold engine, the coolant temperature sensor should read close to 1 volt. When fully warmed up, about 2.5 volts. Readings outside these ranges point to a faulty sensor. Always match code readouts with voltage checks before replacing any parts, and double-check harness connections for corrosion or loose pins. This approach prevents wasted money and narrows the problem to the true culprit. Sticky carbon deposits on the throttle body butterfly can throw off your idle in ways that mimic bigger problems. Over time, oil vapor and dust settle around the throttle plate, causing it to bind or stay slightly open when your foot is off the gas. The engine's computer reads this as a partial throttle, so it keeps adjusting fuel delivery, which leads to that familiar surge and drop in RPMs. Cleaning the throttle body takes about 20 minutes and costs less than $20 in supplies. First, disconnect the negative battery cable to avoid short circuits. Remove the air intake duct, then gently scrub the plate and housing with a soft brush and throttle body cleaner. Avoid scraping the edges, since damage there can cause air leaks. Once everything is spotless, reassemble and reconnect the battery. After a quick restart, you'll often see the idle settle right around 750 RPM as the ECU relearns its baseline. This simple fix restores smooth idle and heads off more expensive repairs down the line. Idle air control valve failure is a frequent cause of idle surges, especially in vehicles built before electronic throttle control took over. The IACV's job is to let just the right amount of air bypass the closed throttle plate when you're stopped. When carbon builds up or oil contamination sets in, the pintle inside the valve can stick, either letting too much air through or barely any at all. A quick test is to unplug the IACV's electrical connector while the engine idles. On a healthy valve, the RPM will drop by about 200, sometimes causing a stumble. If the idle doesn't budge, the valve is likely clogged or electrically dead. For a deeper check, use a multimeter to measure coil resistance across the terminals. Most should read between 12 and 16 ohms. If the reading is out of spec, or the pintle won't move freely after removal, replacement is the best option. Cleaning often restores function if the problem is just carbon. Costs run from $50 for cleaning kits to $150 for a new valve, making this a manageable repair for most DIYers. Vacuum leaks are the #1 reason engines surge at idle, responsible for nearly half of all hunting RPM cases. When air sneaks past cracked vacuum hoses, a worn intake manifold gasket, or a faulty PCV valve, it bypasses the mass airflow sensor entirely. The engine's computer tries to correct the imbalance by dumping in more fuel, but the result is a rough, unpredictable idle. Diagnosing a vacuum leak doesn't require fancy tools. For most DIYers, a can of brake cleaner is all it takes. With the engine idling, spray short bursts around hose connections and the base of the intake manifold. If the RPM suddenly spikes, you've found the leak. The cleaner is being sucked in through the crack. Always work outside or in a well-ventilated garage. Wear gloves and safety glasses, and keep a fire extinguisher nearby. For pinpoint accuracy and zero fire risk, a smoke machine pushes harmless vapor through the intake, making even hairline leaks visible. Fixing a vacuum leak is usually cheap. Replacing a hose or gasket often costs less than $30 and can be done with basic hand tools. Mike, a daily commuter, once faced a $400 sensor replacement quote for a surging idle. Instead, a $10 hose and 20 minutes of work solved the problem. Restoring the sealed intake brings the engine's air-fuel ratio back to its 14.7 to 1 target, stabilizing idle and saving money. Across all 6 causes, one pattern stands out. Idle instability always traces back to disrupted airflow or faulty data. Fixing RPM surges means restoring balance, because a smooth idle is never an accident.